Alright, so for the last video, we talked about what is the data mining, right? So it is not just the summary statistics, it is the second step after the summary statistics, right? And this data mining step will help you to make the decision. And we say we have different kind of modeling methods, right? Just like we have the regression-based modeling methods to make the predictions, right? We can also do the smoothing methods in the time series, right? So here we just introduce another way, another methods, right? And this method is the called the decision tree. Right, so decision tree is a more intuitive way to show the predictive results. Right, so it will show you a tree from the top to the bottom, and then you just follow the classes, follow the groups until the end. Then you will find the predictions. Right, so we'll talk about this in details, and then. Unlike a regression model, a decision tree algorithm, it doesn't find the equation that relates the predictors to the response. We don't have the equation anymore. Instead, it will show you the tree. Right, and here we will have two kind of trees. The first one is the decision tree used on a quantitative variable is called the regression tree. That means if your response variable is a continuous variable, then we just call this decision tree is a regression tree. But if your response variable is a quantitative variable, or we call it is categorical variable, right, then we still can have the decision tree, but this time this decision tree will be called classification tree. Right, so they will look like very similar. It's just based on different types of the response variable. All right, so here we just use an example to show what is the decision tree. All right, so here we still use the housing data, which is the West Foxbury housing data. Right, so this data is already uploaded on your in the module 6. Right, so once you click that, you will see this data. All right, so this data contains these many variables. Right, and then here I just make a list. Right, so we have the total value, the tax of it, the lot square feet, the year it was built, right? Gross area, living area, floors, number of rooms, number of bedrooms, number of footbaths, number of half baths, the kitchen, fireplaces, whether this house was remodeled or not. All right, so actually we want to make the prediction about the house price, right? So of course the total value of the house will be the response variable, right? So since it is the value for the house is in thousands of United States dollars, that means it is continuous variable, right? And then let's look at these variables, these explanatory variables. We see the tax, right? So we say the tax is actually based on the total value, right? Just based on with the same tax rate, right? So actually these two are the same thing. We cannot put the repeated information in our regression, right? So we just delete this variable tax. We don't care about this tax. We use the other ones as my explanatory variable x. All right, and now I will create the decision tree. All right, so this is I first generate a simple one, right? So simple one just with the two variables. Right, so I want to make a decision tree with only the gross area and the number of floors. Right, now I will show you how to generate this tree. All right, I will tell you why this is called a tree. All right, so let's use this real data. All right, and then go to analyze. And then we have a option is predictive modeling. Right, in this predictive modeling, I have another option is the partition. All right, so click that. Right, you'll have a similar output here, right? Similar table here that you need to fill out. So the total value will be the y, and then we don't care about the tax. We use the gross area and number of floors as my explanatory variables first. All right, and then I just click OK. All right, so this is our output. Right, so it doesn't show any tree as what I have in this output, right? Okay, so what should I do next? I will split, right? So you see, once I click the split, this is the total observations, which is total is 5,802 houses. All right, and then after I click the split button, it will be split into two groups. All right, so these two groups is the gross area is less than 3667 and gross area larger equals to 3667. So why these two are separated? Because behind this output, the software gets the regressions, right? So they think these two groups are separated because there is a significant difference between these two groups, right? In the end, they just calculate the range of it and then say, okay, these two groups are the most significant that you need to separate at the first. Right, then if I click the split again, right, you still remember these two groups, right? So less than 3667, larger equals to 3667. And then based on this group, this time split will split this group into subgroups. Right, these two subgroups will still based on the gross area, but this time within this range less than 3667, the jump will calculate that within this group, these two groups are significant different. All right, so now based on this split, this group is split into two groups. If I split again, let me put it up. All right, so if I split again, we'll see now within this group, it is divided into two subgroups, but now it would depend on number of floors. Number of floors less than 2 or larger equals to 2. All right, so actually you can keep splitting, then you will have kind of a tree. Right, so we call here is the root. All right, and then you just keep growing, and then the tree is getting bigger and bigger. All right, and then we say these ones are the leaf ends, right? Because there are no more subgroups anymore, right? So we will have the detailed introduction about the decision tree for the data analysis 3. All right, it will be individual data analysis. I will make another video to talk about the decision tree in details. But here, I just want to show you that you can always generate a decision tree from JMP or from any statistical software. All right, and here I just show you the steps, right? So you click the analyze, predictive modeling, and then partition, and then you enter the response variable, X variables, and then you just use the split to generate the partitions. Right, so now we have a more intuitive way to show the regression, right? So what does that mean? That means it will first divide the whole group by the gross area. That means what? That means the gross area is more significant than the floor. All right. Okay, so then you read from the top until the end to answer this kind of question, right? What if I want to make the estimate, what is the estimated value of a home with 2 floors and a gross area of 4,000 square feet? Right, so how you can get the estimated value for this kind of home? Right, it will be with 2 floors. Do you start from here? No, remember when you read the decision tree, you need to start from the beginning and then go down to each subgroups. All right, so first for this home, the first thing you need to decide is whether the gross area is less than 3667 or larger equals to 3667. It is 4,000 square feet, right? So it will be within this group, right? But after this group, it doesn't have any subgroups based on this output, right? That means it doesn't matter the floor number of floors is less than 2 or larger equals to 2. This is the final result you can have based on this output, right? So what is the estimated value of a home with 2 floors and a gross area of 4,000 square feet? It is just this, right? It will be mean of it, right? So it will be 542.03817 the price, right? So in thousands. All right, so this is the way how you use the decision tree to make the prediction. Next question. Right, what is the estimated value of single-story home with 2,000 square feet? All right, so now we start from the beginning again, right? So this is the top, the root of the decision tree. All right, next you need to decide the home is less than that or larger equals to that. We have the home as 2,000 square feet, right? So it will be belongs to this group, right? Go to the next step. You still need to decide that the gross area is less than 2,595 or larger equals to 2,595. It still belongs to less than 2,595 because our home is 2,000 square feet, right? And then follow it to the next step. Now it will based on the floors is less than 2 or larger equals to 2, right? So this home is a single-story home. That means the floors will be 1, right? So it will be less than 2. So what is the estimated value for this home? Will be the mean of it, which is this, right? So it will be 305.80977 in thousands. Right? Okay, so actually the decision tree provides a very kind of a easier way for you to make the predictions. That's why we call it is predictive model. Right? This is the predictive model method. Right? So it is just used for making predictions. Can you interpret the coefficients? No, you don't have the coefficients. Can you understand which parts play a for example, if the gross area increased by 1 square feet, the home's value will increase how much? You don't know about it because you are not interested in it. We just want to use this decision tree to make the predictions, right? Okay, so this is the example. And then if you keep clicking the split button, right, you will have bigger tree. Then you will have these subgroups will be more and more in details, right? So actually, to answer these questions, you may have different answer, different predictions based on how many splits you have. All right, and then you will have different estimation or prediction for the same home, depending on how big is your tree, how detailed subgroups you have. All right. Okay, so next topic about a decision tree I want to talk about is the how to use the training set and validation set, right? So remember, when we want to make a model, we always want to generate a model and then check whether this model is good or not. So although this is not the general sense model, right? It is a picture, it is a tree, but it is also a model, right? So based on that, I want to check whether this decision tree is good or not. I need to separate my raw data into two sets, right? It's called the training set and the validation set, right? So now I want to show you that how I can make the validations, right? Okay, so this is our raw data, right? And then here I already generate a column. It's called validation. So the variable's name is validation. That means I just randomly choose some of them as my validation set, and then the other of them will be the training set. Right, okay, so now I will delete it and I will show you how to generate this column. Right, so you go to analyze, all right, and the predictive modeling, where you select the partition here, right? So you do not select the partition, you go down to make validation column. Right, if you click that, it will show you that the total rows is 5,802 houses, and then you can always set the proportion of the training set and validation set, right? So here, normally we say validation set, someone also call it test set, but these two are two different things, right? So we do not talk about the test set here. But in your homework, in the MyStarLab homework, sometimes they just call it test set, right? So you just consider it is the same with the validation set. All right, so here I just set the validation set as 0.25, and then training set takes 0.75. Totally is 1. All right, and then I just call it is validation, right? So that it is, we know it is for validation. And then next, you need to choose the way how you choose these observations as training set or validation set. So here, since we just randomly choose some of them as the training set, some of them, the other ones will be the validation set, right? So we just choose it randomly, right, with a random function, right? So just click that, right? Okay, so you will see a validation variable, right? So this variable is for, they have already known that which observation is in the training set, which observation is in the validation set. All right, so now once you have this variable, you can go analyze and then create the decision tree partition. All right, and then I have the total value. And if since we don't care about the text, right? If I use all the variables until remodel, right? And then I'll use all of these factors as my x, right? And then for the validation, I want to check whether the model generated is good or not. So I use this validation variable used in this blank for the validation. All right, and then click OK. You'll have this kind of the same thing here. And then if you keep splitting it, right, you will see 2 rows instead of 1 at the beginning, right? You will have 2 rows. The first row is about the training, and then the other one is about the validation, right? And then what you need to do is to compare their RMSE, which is the root mean square error, which is the SE, which is the standard deviation of the residuals. All right, and then you can see that if these two are close to each other, that means this model is good, right? Okay, so if I splitting it, you will see that there will be some differences, right? So you can just stop whenever you think it is good, right? So as I see here, if I keep splitting it, the difference is getting bigger and bigger, right? So actually I don't want this way. So actually I don't need so many splits. We can stop for somewhere, right? And then I will do again to show you where to stop, right? So let's do again. Analyze, predictive modeling, and then partition, and then use total value as my y and the other ones as my x. I use validation as my validation, and then click OK. All right, and then you will see that there is a go button here. Right, if you click go button here. Right, so I want to show the tree. Right, so I need to ask the jump to show me the tree. Where is the tree? Right, so the tree here is very, very big, right? So this is our tree. Right, so it is a big tree, right? And then let's come back. We don't need this tree. All right, so you see that if I click the go here, that means you don't need to keep splitting it by yourself manually. What you need to do is just go use this button, and then the system will tell you where to stop. Right? So only when you use the validation option, then you will have this go button. And then this go button will tell you where to stop. So here, you stop. The system stopped at 109 splits. Right, that's why we have such a big tree. Then at the end, you will have this. Right, so this will tell you why this decision tree stopped at 109 splits. Right, so you will have 2 R squares. All right, let me see. Yes, so the red line is for the validation set, right? The blue line is for the training set, right? We want to see that at some point, the R square of both sets keep kind of not changing anymore. keep smoothed, right? Keep the same. So actually the system, the software decides that from this point, the R-square of the training set will not change anymore. And then from this point, the R-square of the validation set is not change anymore. So this point is a good point to stop. All right. Right, so let's come back to our chapter note. Right, so for this chapter note, I just used the 2 variables instead of all the variables so that the decision tree will look easier. Right, it will not be big trees. All right, and then you will have the 2 rows here. Right, one is for the training data, one is for the validation data. Right, and you will also have how many observations contained in each data set. All right, so here I kind of set, I think is 0.5 and 0.5, so kind of the same thing. All right, and then you will have the R squares, you will have the the root mean square error. Right, you will see the mean square error is very close, so it is a good sign that this decision tree is good. All right, okay. And then if you look at the root, the ROOT, the root of the decision tree, you will see that the count is only the number of the training set. You see that? Right, it will not cover the observations in the validation set because this decision tree is based on the training set. Right, it's not based on the validation set. It will only use these many observations to generate the decision tree. All right, and then another thing I want to show you is if you have the decision tree, all right, and then if you use this, click this red triangle here and go down, there are 2 options. Right, the first one is called the column contributions, and the other one is about the split history. Right, so you will see these 2 outputs. The first one, split history, is the way to show you how the R-square will change over the number of splits. So we have already talked about that. And this is the column contributions table. So what does that mean? When I add all of these as my explanatory variables, this proportion tells you the proportion of the contribution of this variable in this regression, in this model. All right, so that means what? That means the living area is the most important variable to make the prediction about the house price. Right, it takes 83.14% of the contribution. Next will be the lot square feet. Next one will be the gross area. Next one will be the floors, right? So you will see that decreasing ones. That means from here, the number of half bathroom, the number of rooms, number of bedrooms, number of kitchen is not very important because it just contributes about 0 to the predictions. Right, so actually, even though you don't need a decision tree, even though you want to get a model, all right, multiple regression model, you can always generate a decision tree first and then look at the column contributions, including all the explanatory variables together. And then you can choose, okay, since this is the most contributional thing in my model, so of course I will include this in my model, right? Include this in my model, and at least 1, 2, 3, 4 will be included in my model. So it will be much easier for you to generate the multiple regression model, right? So they are related. All right, so the last topic I want to talk about the decision tree is, what if we have a binary response? What if our response is not continuous variable? That we call it is regression tree. What if we want to have a classification tree? That means the response variable is categorical variable, right? So here, what if your response is a binary response? That means either yes or no, right? Either 1 or 0, right? So let's look at our data. Let's close that, right? Okay, so let's look at our data. Right, so we have another column. This column is called the value larger than 500. So what does that mean? I just make the categories, make the two groups based on the total value of the house. That means if the house price is larger than 50, for example, larger than not 50, larger than 500, for example, this house, the price is larger than 500, then I just make the value of it in this variable to be 1. All right, okay. No, this one will be 1, and all others will be zeros. And then let's say another larger than 500. For example, this one. All right, and then it will be also called 1 in this variable. That means if the house price is larger than 500, it will be equals to 1. If it is less than 100, less equals to 100 or 500, then it will be 0. All right, so if you have this kind of variable, binary variable, how you can make a decision tree? The steps will be exactly the same. Analyze, predictive modeling, partition. All right, and then now we use this one, the binary response variable, as my y. And then let's say I use all the variables as my x. All right, and then I use the same validation option here, and then click OK. All right, and then I click Go. All right, then this will be my decision tree for the binary response variable. All right, so now let's come back to the chapter note. It will be easier to look at. All right, so here we still we will have this big decision tree. All right, and then you will see that the red will be 0, the blue will be 1. Right, so in the default of decision tree, the zeros will the red will be 0, the blue will be the 1. Right, so if it is 1, if it is blue, that means their house price is larger than 500. Right, if it is red, that means the house price is less than 500. All right, okay. In the end, this is the decision tree. The question, which is the best node for the expensive houses? Think about it. Expensive houses will be larger than 500, right? That would be the 1. That would be the blue ones, right? So what is the best node for the expensive houses. That means the group, the knot, we'll talk about that. The knot, that means there is no any subgroups after this step, right? So actually, how many end nodes for this decision tree? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So in these 10 nodes, end nodes, which one is the best node for the expensive houses? Of course, will be this one, right? Within these subgroups, all of them mostly, right? So almost all of them are expensive houses, right? So it will be how to describe it. It will be more than one fair places, right? And then the gross area should be larger, equals to 4322, and living area is larger than 2352, and living area is larger, equals to 2144. Then how you describe this kind of house? Can you just describe the living area twice? Actually, no, right? So since it is larger equals to that, of course it will be larger equals to this, right? So actually how you describe this group, it will be the fair place larger equals to 1, and the gross area is larger equals to 4322, and living area is larger equals to 2352. But this one will not be a range for the living area because it will be belongs to this, right? Okay. So I think that's enough for the decision tree. And in the data analysis 3, before the data analysis 3, I will generate a video for you to better understand the decision tree, right, in details. For now, you just understand if I give you a decision tree, how you can make the estimation, how you can figure out that for each group, which one, that means this one is these 3 groups, subgroups are almost, let's say, cheap, not expensive houses, right? So the last thing for this video is just a summary, right? So what is the data mining, right? So data mining models not only for the regression models, we have many other modeling methods, right? The smoothing methods for this is decision method, right? All of these can make the predictions based on different situation, different data set, right? You can choose your own modeling methods. And here are the checklists that you should know from this lecture, and you need to know what is the where does the big data come from, right? So what's the difference between the descriptive analytics and the predictive analytics, right? And then what is the difference between these two modeling, right? And then what is the difference between the regression tree and the classification tree, right? And then with giving you a tree model, how you can make the predictions. You just goes from the top to the end, right? And then you also need to know how to use JUMP to construct a decision tree model. Although you will have the outputs in your exam, but the data analysis 3, you still need to know how to use the JUMP to construct a decision tree model, right? We'll talk about this later in the data analysis 3, right? So I think it is quite easy for these two parts, right? So the decision tree is quite straightforward. Once you have the outputs, you just go from the top to the bottom, right? And then for the introduction, I think the introduction is very easy to understand. There's no much things you need to remember, just to kind of see the difference between the two things, right? So next video I will talk about the details for data analysis 3 and how you generate the decision tree one step by one step, right? So we will have our practice, kind of a practice guide for you to complete the data analysis 3. All right, okay, so see you in the next model. See you in the next video. All right, bye.